So this video will cover finding segment lengths in circles. So before we do that, we want to talk about a little bit of vocabulary. Segments of a chord are referring to the pieces that result when two chords intersect within a circle. So each of these chords is a segment of a chord. A secant segment is a segment that intersects the circle twice. So right here we have a secant segment, and an external segment is just the part that is outside of the circle on a secant. So the secant segment refers to the whole thing. External segment is just the outside part. So first of all, we'll talk about segments of chords. If I have two chords that intersect within a circle, then their lengths, if you multiply their lengths together, you're going to end up with equal products. So what I mean by that is that in my picture here, if I take A times B, the two pieces that chord are cut into, it's going to equal the product of the other two pieces, C times D. So for instance, if I told you that A was equal to 8 rather, and C was equal to 6, and D was equal to 4, then I know that 8B has to equal 6 times 4, or 24. And so I'd be able to figure out that B was equal to 3. So if we look at example 1, we're going to find the length of ML and JK. So now this one, same thing, we're going to multiply together the pieces. So I'm going to take x plus 3 times x plus 1. And that's going to have to equal x plus 5 times x. So if I go ahead and do the multiplication, I get x times x is x squared, x times 1 is x, 3 times x is 3x, and 3 times 1 is 3. And on the other side, x times x is x squared, and x times 5 is 5x. So first of all, I see that I have an x squared on both sides, so I can go ahead and cancel those out. And then if I combine my like terms, on the left side, x plus 3x is 4x. So I have 4x plus 3 is equal to 5x, and we subtract the 4x, and we get that x is equal to 3. However, I'm not done with the problem because they want me to find the length of ML and JK, so you have to plug that 3 back in. And so ML is the whole thing, so x plus 3 becomes 3 plus 3, or 6, and then this part down here would be 3 plus 1, or 4, so 6 plus 4, ML is equal to 10. And then JK, when I plug it in, 3 plus 5 is 8, and this is just a 3, so JK is 8 plus 3, or 11. So here's one for you to try on your own. I want you to find the value of x here. Okay, so when you set that one up, you would do 6 times x equals 5 times 12, and so you should have gotten that x was equal to 10. Next, we'll look at segments of secants. So the way that these work is that the outside piece times the whole thing is going to equal the other outside piece times the whole thing. So in my picture, that means that A times A plus B is going to equal C times C plus D. The outside times the whole thing is going to equal the outside times the whole thing. Of course, this whole length here is A plus B, and this whole length here is C plus D. So if I look at example 2, again, I've got the outside times the whole thing equals the outside times the whole thing. So first of all, you want to remember to check and see what is the whole thing. So 4 plus 6, that whole thing is 10. And over here, I don't know what x is, but the whole thing is going to be x plus 5. So the outside, 6, times the whole thing, 10, has to equal the outside, 5, times the whole thing, x plus 5. 6 times 10 is 60, and then I distribute my 5, and I get 5x plus 25. And then if you subtract 25 from both sides, you get 35 is equal to 5x. And so x would have to equal 7 in this case. So here's one down here. Let's move that up a little bit. There's one for you to solve on your own. Go ahead and pause the video now. Okay, so when you set that one up, you should have said 6 times 14 equals 7 times x plus 7. And then when you solve it out, you should have gotten that x was equal to 5. All right, next we're going to look at segments of secants and tangents. So the way that these work is that the tangent squared is going to equal the outside times the whole piece for the secant. So the tangent squared, take this times itself, is going to equal the outside times the whole thing. And again, the whole thing over here is going to be A plus B. So that means that C squared would equal A times A plus B. So if we look at example 3, we're going to find the length of RS, which is x, and my whole thing on this side is going to be x plus 12. So the outside piece, or the tangent rather, tangent squared, so 14 squared, is going to equal the outside, x, times the whole thing, x plus 12. So 14 squared is 196. X times x is x squared, and then x times 12 is 12x. So the x squared is not going to cancel out this time, which means I have a quadratic equation. And so I can either solve it by factoring or by the quadratic formula. In this case, it's not actually going to factor out. Well, before I can do any of that, I first need to subtract the 196 and get everything on one side and make it equal to 0. So now I have 0 is equal to x squared plus 12x minus 196. So there's nothing that's going to factor evenly. I have to use the quadratic formula for this one. So you'll recall that when you're using the quadratic formula, first of all, we're going to assume that there is a 1 in front of that x squared. And so the x squared coefficient is a, the x coefficient is b, and then the constant is c. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now I'm going to plug in those values of a, b, and c into that formula. So negative b is going to be negative 12 plus or minus the square root b squared, so 12 squared, minus 4 times a times c all over 2 times a. Alright, so first of all, you want to be careful with your negatives. Notice here I have a negative and a negative, so that's going to end up becoming positive right there. So now I have x is equal to negative 12 plus or minus the square root. 12 squared is 144, and then 4 times 196 is 784, and that's all over 2. And so that's going to equal negative 12 plus or minus the square root of 928 over 2. Now what you have to remember is that plus or minus, that means there's actually two answers. So let me give myself a little bit more room here. Alright, so there are two answers. There's a negative 12 plus the square root of 928, over 2, and then there's negative 12 minus the square root of 928 over 2. So right off the bat, I already know that I can throw out the negative answer because length cannot be negative. And I just have to worry about my answer that's going to come out positive. So if we plug negative 12 plus the square root of 928 and divided by 2 into our calculator, we get that x is approximately 9.2. You want to be careful when you are doing this in your calculator. You want to make sure that you either use parentheses or hit your equal sign before you divide by the 2. So I would recommend that you put parentheses around it, and you would put it in your calculator, negative 12 plus the square root of 928, and then end the parentheses, and then do divided by 2. And that's going to work in your calculator. Because if you don't have the parentheses, it's just going to divide the 928 by 2, and you're not going to get the right answer. So you might want to double check that you can get 9.2 when you put that in your calculator, just to make sure you're using your calculator properly. Alrighty, so we have one more for you to try on your own. This one is also not going to be factorable, so you're going to have to use the quadratic formula for this one as well. So give that a try. Pause the video now. Okay, so when you plug it in, well, when you set it up, you'd have x squared equals x times x plus 6. And so you end up with x squared plus 6x minus 64 equals 0. So a is 1, b is 6, and c is negative 64. And so when you plug it into the quadratic formula, you should have gotten x equals negative 6 plus or minus the square root of 6 squared minus 41 times negative 64 all over 2 times 1. Then when you simplify it, you should get x equals negative 6 plus or minus the square root of 292 all over 2. We're going to throw out the minus square root 292 and just do negative 6 plus the square root of 292 divided by 2. And when you put that in your calculator, you should get 5.5. And that concludes this video. Thank you.